Okay, but a really important situation in physics is when you have no resultant force on an object. So what does that look like in a diagram? Well, here's the force diagram for a plane flying at constant velocity. So we've got the lift balancing out the weight and the thrust cancelling out the drag there. And so I've drawn a scale diagram just to make it really obvious, 1 centimetre to 200 kilonewtons, and I'm starting here. So I've drawn the thrust, plus the weight, plus the drag, plus the lift, and what's the answer? Well, this is where I started. How far is it from where I started to where I finished? 0. So when you add these 4 forces up, you get 0. As a general rule, if you add up forces with a diagram and the answer is 0, you're going to get a closed shape. And the example that's explicitly in your syllabus, so you might have seen this if you've looked at your specification, triangle of forces, is if you have 3 forces and that happens. So if I add together, let's say that this was a ball flying through the air and we've got its weight downwards, the force, a thrust force from the wind horizontally, and then this is the drag force. It must be heading that way. It's got a drag force backwards there. So if I add up these 3 forces, so there we go with the weight plus the thrust plus the drag. Now I know, because I've been told that those forces add up to 0, I know that I have to get a triangle when I add them up. There has to be no distance between where I start my first arrow and where I finish my last arrow. So here is question 2 for today, and notice that they say use a labelled vector triangle. So they are telling you you have to do it by drawing one of our triangles like we've just seen. Okay, pause the video now if you'd like to have a go yourself. So we always start with a free body diagram, and we've almost got one here, but I'm just going to draw it again just to make it a little bit clear. And that angle there is 35 degrees. Okay, I'm just going with algebra this time. If you've done a scale diagram, that's brilliant, but I'm just going to go with algebra this time. So I've got so I'm going to do W plus P plus the tension must add up to 0, so I'm going to get a triangle. I know that now. Then let's get this right. So that angle there to the vertical, that's the one that's 35 degrees. And W is 280 newtons. And now I'm just going to use trig. Tan 35 is opposite over adjacent, giving P is 196 newtons. So here it's 1 mark for the diagram, 2nd mark, 3rd mark, 4th mark. Okay, and then part B asked, state and explain what happens to the tension if the swing is pulled so that you get a larger angle there. Well, if you want a large angle there, then you need to have pulled harder. P needs to be bigger, and then that means that W plus P will be bigger, and that means that T must also be bigger because they still have to add up to 0. So something like 1st mark for saying W plus P will be bigger, and 2nd mark for saying so T must be bigger as well, so that they add up to 0.